We're studying IGCSE chemistry and we're starting chemical reactions and equilibria 2. Right? Reactions and equilibria 2. I will revise everything we did in the last class and learn new things. Now, the main focus of this class, the agenda of today's class is, just a second. Is to look at the Haber process, contact process, and fertilizers. Fine. Now, the first thing we need to look at is the Haber process. Haber process. Now, you should see it right here. Niranjana, you have written this, yes? Zara, read it out once.
Sir, okay. So Haber process, conditions, temperature 450 Celsius, pressure 200 atmospheres, catalyst iron, source of reactants nitrogen from air, hydrogen gas from methane, and then the process, the chemical reaction.
Chemical reaction right here. How do we get methane? How do we get Haber process? This right here itself is 3 marks in the exam, or you should even write this as 10 marks. Because the thing is, this process will be asked you in every exam. This is a guarantee that they will ask you. What is the equation of the Haber process? Now, please do one thing. Zahra, take a screenshot of this.
Okay.
Now, if you can write this down, that would be better. But take a screenshot for now.
Yeah, I will write it down.
Screenshot taken?
Yes, sir.
Write it down later. Then I'm adding some new things to this. Just a second. We have done that. Just a second. Niranjana, you have to write this as well.
So which one?
This one, sources. In contact process, we also have the sources. Like, where are the reactants coming from? The source of reactant. Now, if you can memorize all of this, you can answer most of the questions, but we have to practice questions. That's the more difficult part. So I'm finishing everything which is required in the syllabus, then we'll start practicing. Now, source of reactant for this is sulfur. What is the equation for this reaction? Just a second, I'll give you the equation, which is, add this in your writing. The equation for contact process is 2s2, 2so2 plus O2, 2so3. That's it. Okay. Now, all of these are gas, by the way. You need the symbols as well. Sorry. You need the symbols, write down the symbols. All of these are gases. But in this guy, yeah, all of these are gases. Fine. Zahra, write down the contact process. Take a screenshot and start writing.
So,
The source of sulfur in the contact process is from a just a second. These two. Or that's it. Now for oxygen, we have air. That's everything you need for contact process in the exam. Well, everything you need to memorize, and the understanding part, we'll look at it in a second. Now tell me when you've written or finished taking a note of this. Niranjana,
I
write.
finished.
Finish taking a screenshot. Niranjana, write this in your notebook. This part and this part. The new things, right? Tell me when you're done writing. Meanwhile, Zahra, start writing the part in the orange one, the equation for contact process and the source of reactants. Okay?
Okay.
We did not write this in the last class. Zahra, start writing from the Haber process.
Okay.
Niranjana, check whatever is new here, whatever you have not written, write it.
No, ma'am.
Now, guys, you only have 5 minutes to do this, and then we'll have to move on. So write as much as you can in 5 minutes.
Ores. Sir,
Yes.
what's the meaning of ores?
Say that again.
What's the meaning of ores?
Ores. Yeah, we'll talk about what are the meanings of everything, right? Now you're not supposed to just memorize this without understanding. I don't usually do that. But first write it down, and then I'll tell you what it means. Ores means, you know, those rocks in the mountains, right? Which you mine. After you like dig a rock up, you have this big ore of sulfur. It's like a rock. I'll show it to you. Now, can you see this image right here?
So what's the yellow thing?
That yellow, this yellow stone is sulfur. That is the ore of sulfur. Is that clear?
So ore means the pure form?
The pure form in the ground. It's not pure, it's impure, but it's in the ground. That's what it means. Mineral. This is a mineral. Makes sense? Okay. Now do the other stuff. How much have you written, Niranjana and Zahra?
I'm on contact process.
On contact process. All right. Fine. Continue. Finish quick. We have to talk about a few things which are remaining.
Done, sir.
Done. All right. The whole thing is done.
Yes, sir.
Okay. Even the conditions, even the stages, and the equations.
Yes, sir.
Okay, that's good. Alhamdulillah. Fine. Let's continue. I hope Niranjana, you have finished as well. Now we're going to look at why we need the why we choose the conditions, right? Why we choose, or reason for choosing the conditions for Haber process. That's what we're starting with. Okay. Now, what are the conditions of Haber process? Say it to me. Zahra,
Yeah, should I tell it by heart or like?
read it from your notebook.
Okay, by conditions.
Yeah.
Okay, so the condition, the temperature is 450 Celsius.
Temperature is 450. Okay. Temp is 400. Temperature is 450. Right. Let's stop here for a second. Now, why do we have 450 degrees Celsius? Why do we take this? Right. The thing is, let's look at the reaction of the Haber process. It is N2 plus 3H2 gives us what? Niranjana? Zahra, read the equation from your notebook for Haber process. Read the Haber process reaction equation. It's N2 plus 3H2 gives us 2NH3. Okay. Now, Zahra, can you see the symbol right here? This arrow, the two-sided arrow like this. Can you see it?
Yes.
That means equilibrium. What does that mean? Sorry, not equilibrium. You should know it's a reversible reaction. What does it mean? Reversible reaction. Okay. So this is a reversible reaction. Fine. Okay, that's okay. What do we know? Why do we care about this? Another thing, go to your reactions and add one more thing here. That the Haber process is delta H negative, which is called, that means this is exothermic. Write this in your notebook. In front of the reaction, write delta H is negative, exothermic. Now, whenever the delta H is negative, that means the reaction will be exothermic. They will give you the delta H value in the exam.
How will they ask us this question, sir?
Yeah, we will solve these papers in a second. Now I'm just giving you what to write. We'll start so as soon as you can write all of this. This is a long chapter, right? We'll practice questions as soon as we finish. Okay. Now please write this quick. Write it quick. Yeah.
Done, sir.
Done. Okay. Just a second. Okay. Let's look at the contact process. The same thing is true for contact process. It is delta H is negative, which means it is also exo. Write this down. Right? If you're done, let's move on. Now, since I know that the Haber process is delta H negative, okay, so it's going to be exothermic. Now, okay, now we need to realize that, please write this down. Lower temperature favors exothermic reactions. Exothermic reactions. This is what you're writing in your notebook. Below temperature. After the reaction, the equation here. Lower temperature favors exothermic reaction, but higher temperature gives higher or increases rate of reaction. So
But sir, Haber and contact process, they both have the same temperature.
yeah, they have the same temperature. Both of them are exothermic. Right now we're looking at Haber process only, not contact process. Okay. Now why are we using this? Why do we use 450? Because Zahra, read this right here. Zahra, read this line.
Lower temperature favors exothermic reactions.
Niranjana, come on, focus. Read the line on the board.
Lower temperature favors exothermic reactions.
You know, right? Why? Why? Because exothermic causes temperature to increase. It does the opposite. Make sense? Because if you have lower temperature, if you decrease the temperature, exothermic will cause temp to increase. That is why it is favored. Now you don't need to understand this right now. Please just memorize this. Lower temperature favors exothermic reaction. Is that clear, Zara?
Yes, sir.
Now, if I want Hebel process, what is Hebel process? Is it exothermic or endothermic?
It's exothermic.
Exo. So if I want this reaction, should I use a low temperature or high temperature?
High.
I need, read over here. Read this line
Oh,
again.
yes, sir. Lower.
Lower. So if I want exothermic reaction, I should take lower temperature, yes?
Temperature.
But is 450 low or high?
So can you repeat your question
Yeah, I'll
again?
tell you. Is 450 degrees Celsius low or high temperature?
It's higher, so
High, it's very high. So, but why are we taking high if we should take lower? Because read this line now. Niranjana, read the line on the board.
Okay, sir. But higher temperature increases rate of reaction. So
Rate of reaction. So, just a second, I'll write it down. So, to have a faster reaction, we take a compromise temperature of 450, right? Now read it again from the beginning. Azahra, read it.
lower temperature favors exothermic reactions, but higher temperature increases rate of reaction. So to have a faster reaction, we take a compromised temperature of 450 Celsius.
Celsius.
Degree.
So even though lower temperature will give us more ammonia, what does this mean favors? What is the meaning of favors? Favors means that more ammonia is made. Okay, the word favor here means more ammonia is made. But now it's a choice. Do I want more ammonia or do I want fast reaction? More ammonia or increases rate of reaction means fast reaction. It's your choice. What do you want? In real life, we choose fast reaction because if we have a fast reaction, it actually makes things easier for us. So we take a compromise of 450 degrees. Is that clear? Can I move on? Please,
Yes, sir.
now you don't have to write this notes right now. I'll tell you what to write later. Let's continue. We look at the next thing. What is the other condition of Haber process, Zara?
The condition of Haber process is pressure,
What is the pressure?
or it's 200 atmospheres.
200 atm. Okay, 200 atmospheres. Isn't that too much? Or it is 200 atm. Now, why do we need 200 atm? Because I'll tell you. High pressure favors side, let's say, side with lower number of particles. Okay, favors reaction side with lower number of particles. The next thing is, just a second, give me a minute. Please start writing this down. For the conditions, write this down. Actually, the whole thing. And yeah, the whole thing actually. Write the whole thing. Because that is as brief as I can make it. So please write this in your notebook. will be
Sir, should I write about the pressure too?
yes.
Okay.
Niranjana, what is your progress?
I'm writing it.
Writing it down. Okay. Now I need you to make a change. After favor, you should add yield. Favor is yield. So after the word favor, add yield. The word yield itself means the how much product is made.
Sir, can you repeat it again?
Yield means how much product is made. How much product or how much product is made. Right? So just write whatever is in the board. You don't have to write how what yield is, or you can write it as well if you want. Okay, but these parts here, I'll tell you, this is important. All of this is important. So please finish that and tell me when you're done.
Done, sir.
Done. That's good. Everything?
Yes, sir.
Yeah. Niranjana?
Yeah.
Yeah. All right. Now let's find pressure. So we know why we're taking the temperature and pressure. About the catalyst, just a second. What is the catalyst? What is the other condition? Tell me, Niranjana.
It's iron.
Iron. So what it does is, what does iron do? Catalyst. Please make sure this catalyst is iron. Does not affect equilibrium or yield, right? Slash yield. Equilibrium slash yield. The more the forward reaction is favored, the more the equilibrium is towards the forward reaction. Or let's say you have two reactions here. This is what you have. Right? Just a second. This N2 plus 3H2 gives us 2NH3. Now, the more the reaction of this guy is favored, the more this is favored, the higher the yield, the higher more product you'll have. So you need to favor this, the right side of the reaction. How do we favor it? By using a high pressure and a low temperature. That's how we do it. Now, especially just write this down. Iron does not affect equilibrium rate, but increases rate of reaction by decreasing activation energy. Write this and tell me when you're done.
Done, sir.
All right. Take your time. I'm going to give you the reason of Reasons of choosing contact process conditions. Now the conditions for contact process are the following. First, you have temperature of how much? 450 C. And finally, now guys, come on, write quickly so we can start practicing. The temperature is 450 and pressure is 2 atm. Now, why do we need temperature? High pressure, low temp favors yield of exothermic reaction, but high temperature increases rate of reaction. So 450C taken. 450C taken as compromise. Same thing for both. Next, pressure. Or you don't have to write this, just say same as for Haber process. Same reason as for, write this thing here. Now for pressure, the last thing is that high pressure favors yield of but yield is already very good, very high. And high pressure is expensive and dangerous. So we take 2 atm. Now finish writing this, tell me when you're done. This concludes our chapter. The only thing left right now is, well, that's it. There's nothing else. I'll give you some things on nitrogen fertilizer. We'll do those questions. As soon as you finish writing, I'll give you a question.
Done, sir.
Done. Good. Niranjana, done?
Yep.
Yeah, fine. That's everything you need to memorize by heart. Let's start with the first question. Read the question, Zara.
Sulfur is an important element. Explain how burning fossil fuels containing sulfur leads to the formation of acid rain.
Acid rain. Now, acid rain. Fine. Write the question. Write this question in your notebook. I'm giving you the answer. Now, this is not in the chapter of equilibrium, but it will come in your paper. Okay, so quickly write the question, and actually we'll get back to this later. Don't write it. Skip. Read the next question, Niranjana. Here, sulfuric acid.
Sulfuric acid is manufactured by contact process. One step in the contact process involves a reversible reaction in which sulfuric trioxide SO3 plus is formed. Write chemical equation for this reversible reaction. Include the correct symbol
Right.
to
Okay.
show
Quick.
that the
Now, Zara, tell me the answer. And Niranjana, tell me the answer. Right. Check your notebook. Which stage has SO3?
it will be SO3.
Okay, no, it's formed. SO3 is formed.
Then what we have to write?
Check your notebook. Right, I'll tell you where it is. I'll show it to you just a second. Look, this one, stage
Yeah,
number.
that's why I told you.
Have you written this? Stage 2.
Yeah, I have written this.
SO2.
So it will be H2S2
2SO2.
and
Yeah. So this will be 2SO2. You have to memorize this by heart. Equally, 2SO2 plus O2 gives us 2SO3.
O2 plus 2S2.
And you
It
need,
will be
yeah.
yeah.
Any
So what
doubts
they
here?
meant by formed?
Formed, that is the product. ये बन रहा है, right? ये product है आपका.
Okay.
Now, okay, Niranjana, next question, answer.
Next question. State the conditions and name the catalyst used in the reversible reaction.
Reversible reaction, okay.
In contact process, if the temperature will be 450 degrees Celsius,
Yeah,
pressure will be 2
yeah, to what? To ATM.
atmosphere.
Yeah, to atmosphere. Write the whole thing, that's atmosphere. Don't write
Okay.
ATM.
Yeah, catalyst will be V oxide.
V2O5. Vanadium dioxide. Write the whole thing. Don't write V oxide, write whole thing always. Okay. Now next thing.
Describe how sulfur trioxide formed is converted into sulfuric acid in the next stages of the contact process.
Right. Okay. Now you have to write this in your notebook. Write the question in your notebook. This guy. I'll tell you how to write the question. How is sulfuric acid formed from sulfur trioxide? Okay, that's your how is okay. Okay, that's it. That's the question. Write the question in your notebook. I'm giving you the answer. The answer is this. Just a second. This. Write the whole thing. Don't put brackets there. Just put concentrated H2SO4. That's the first step. The first step. Okay. So step 1. After you have SO3, then step 2 after that is H2SO4. This. Then this is okay. By diluted is diluted by adding to water. Okay. H2SO4. After this, you should write to form H2S from oleum. That's it. Now there's the answer. How is sulfuric acid formed from sulfur trioxide? Now write this down. I'll tell you which stages there are. I've given you 4 stages, yes?
Yeah.
Okay. Now write this down first. I'll tell you which stage is this. To make right after this, to make sulfuric acid. Sulfuric acid.
Okay.
Done. So what you do is basically look, you take SO3 gas, you add it to already which you have sulfuric acid. So you make this new highly concentrated sulfuric acid, and then you dilute it with water. Okay, you know this. Now, can I do the next question?
So, but Zara is not here. I'm without.
Let her join. Do you have any questions over here?
No.
Ask her to join.
Yeah.
Because see, we finished the chapter. Now we're just practicing questions. So if let's say we get only 1 hour, then we can practice almost everything in this chapter. Since she's not here, I'm going to start. Okay. Now, Niranjana, read the question. Question 2.
Ammonia is an important chemical. Ammonia is manufactured by the Haber process. The reaction is reversible. What is the sign for a reversible reaction?
Right. Sign for reversible action. Tell me.
Sir, I know how to draw it, but I don't know how to tell it to you.
Yeah, that's not. If you can't explain it, you don't know it. 2 arrows like this.
Yes, sir, I know how to draw it. That's what I said, but I don't know how to tell this arrow to you. This one.
Right. I know that's okay. Okay. Now let's continue. 2.
State the essential conditions for the manufacture of ammonia by the Haber process. Starting from hydrogen and nitrogen, include a chemical equation to show the reaction which occurs.
Okay. Just wait a second. I'll show you the answer to this. Tell me the answer. What is the question? This is the answer right here. Read it, Niranjana. Or I'll just write it for you. The pressure is how much? 450? No pressure. That's 200. 200 atm. Temp is 450. Catalyst is how much? Tell me. Catalyst is iron. Yes. And then finally we have the last thing, which is the equation. Equation is, tell me, Niranjana, what is the equation?
That's it?
That's it. Yeah, full marks.
Really?
Yeah, that's it.
So, but doing chemistry with you is easy, but when I do it by myself, it's hard.
So then it's not going to work, right? If you cannot do chemistry on your own, then Niranjana, you have to make a difference. There has to be something which you have to do differently. And what differently you have to do, I'll tell you. You have to practice questions on your own, right? Because what's happening is I'm telling you everything already, and then you don't have to think a lot. But in the exam, it's all you who's thinking. Yeah, I won't be there in the exam. So equation, what is the equation? Tell me.
For Haber process?
Yeah.
For Haber process, it is CH4 plus 2H2O gives CO2 plus 4H2.
But that's the wrong one.
Then
I need it for the ammonia one, the main reaction. That's for making hydrogen. I need the reaction for
the main
making
reaction, it is H2 plus 3H2 gives
N2 plus 3H2. Have you written it correctly?
Yeah.
N2 plus 3H2 gives us?
It gives us 2NH3.
Now I need the state symbols. What are the state symbols?
N2 is solid.
No, all of them are gases.
Really?
Yes, change it. All of them are solids. Sorry, no, all of them are gases. All of them are gases.
I didn't write the state symbol before.
Write it down right now. I asked you to. They're done. Just add it there.
Yeah, no.
Okay. Now state the same is for the main reaction of the contact process, right? The one with sulfur trioxide. This one, SO2 plus O2 gives us 2SO3.
Yeah, that one you gave me, so I wrote the state symbol.
What are they? Tell me.
All are gases.
All are gases. See, everything is gas. Just write gas there. Okay.
Yeah,
Except
that one you give, but for this you didn't give, so I didn't.
I did. You didn't write. Now it's written. Yeah. Now let's do this one. Name one raw material from which is a source. Source. Tell me. Source of hydrogen. What is the source of hydrogen? Tell me. Read your notebook.
From the air.
No, hydrogen is not from the air.
Hydrogen. From methane.
Methane. Easy. Got it.
Yeah.
That's it. So that's this process. This question is done. Let's try another one. Something different. Equilibrium. Now, one thing is we haven't done fertilizers. We'll do that afterwards.
Okay, so class is over?
No, it's not over. The time is not even over. Please ask Zahra to rejoin. If you want, let's just message her, and she should rejoin. Now read this question on the board. Question 3. Read the question.
Under certain conditions, the reaction reaches equilibrium. PCl2 gas plus Cl2 gas gives us 2Cl gas. State and explain the effect, if any, on the position of equilibrium if the pressure is increased or the conditions are changed.
Yeah, so tell me what happens. What happens to the position of equilibrium if pressure is increased? Now write the question down. First, write the question down. The question is, this is the question. PCl3 plus Cl2 gives us, you don't need to write the state symbols. This is the question.
Increasing pressure, the less particles will be formed.
The one with the side with the side with the less particles is favored. Yes?
Yeah.
Yeah, so how do we write it? Please first write this down. Okay. Effect on EQM of increasing pressure. This is the question write it in your notebook.
So I can't see the book. Oh, yeah, now I can see.
The answer to this question is, according to Le Chatelier's principle. Now, by the way, Le Chatelier, huh? Okay.
What's up?
Nothing. It's Le Chatelier. Yeah. A lot of people may say Le Chatelier or Le Chatelier or something like that. That's wrong, right? You should tell them that's wrong. Now Niranjana is the one who is the intelligent one in the class, so just tell them it's Le Chatelier. Yeah. Principle. Reaction side with lower number of particles is favored. Okay, so equilibrium moves to the which side? Tell me. To the right side.
Yeah.
Or equilibrium moves forward. Now you have two reactions, forwards or backwards. Now you tell me which of these sides has more number of particles. First, tell me how many particles you have in the reactant side.
1.
No, not 1. This is 1 here. This is 1 here. So we have total of 2. Yes.
Yeah.
And then on the product side, how many?
It's 1.
1. So which has lower side?
The forward one, right side.
The right side. So it's not the right side, it's the forward side. Is it clear?
Yeah, forward.
Forward. So I'll say the equilibrium moves forward. That's 2 marks. 1 mark for this and 1 mark for this. If you want, you can add one more thing here. Please add it. Okay, just a second. Sorry. According to Le Chatelier's principle, equilibrium opposes change made. So higher pressure favors with less particles. Lesser particles, lesser, let's say, lower number of particles. So equilibrium moves forwards. Now this is for 2 marks. You need to write exactly this in the exam. Is that clear? This is the format. Any doubts?
No.
No. So okay, that's good. No doubts. Fine. Just give me 1 second. Let's try another one. Yeah, this is perfect. This is perfect. We have a pretty good question here. The last one today. Now, Niranjana, whenever you get a question like this about position of equilibrium, okay, this is the format of the answer. Is that clear? This is how you write the answer always. So whatever they may tell you, all you have to do is, first, this is 1 mark. This will be same for all questions. Is that clear? Same for all. If you just write this, you'll get guaranteed 1 mark out of 2. Okay?
Okay.
So even if you don't understand the question, write this part. It is same for all equilibrium position. And in your question, say effect on position of equilibrium. Now, have you written this down on your notebook?
Yes.
Fine. Then let's move on to the final question today, which is this one. Read the question.
So I can't see.
You can't see it. Is it loading now? Can you see it?
Yeah. Yeah, now we can.
Okay, tell me. So read it. Come on.
The ammonia is produced in Haber process. The equation for the reaction is shown. N2 gas plus 3H2 gives 2NH2 gas. In the Haber process, a temperature of 450 degrees Celsius, a pressure of 200 atmospheres are used in the presence of finely divided iron. A larger equilibrium E, ammonia would be produced if a lower temperature and higher pressure are used. Explain why lower temperature and a higher pressure are not used. Lower temperature.
Tell me, read your notebook. Why is low temperature used? Why is low temperature not used? So in this, what you have to write is reason for choosing Haber conditions. For choosing Haber conditions, in that section you should look for temperature. Choosing condition of Haber. In your notebook, find this part. Reason for choosing condition of
It favors exothermic and heat is released into increasing the temperature.
No, that's not the correct answer. Temperature. Okay, I'll show it to you. Reason for choosing condition of Haber, temperature. Where is this? I'll show it to you. Just a second. Look. Read this, please. This part. The part on the after the but. Yeah. Right, that one. Can you see it? But this for pressure for this is for reason for choosing contact process. I don't want that one. I want this one. Reason for choosing condition of Haber process, temperature. Now you tell me. You have to write the whole thing. Remember? Now read this part.
Lower temperature favors exothermic reaction, but higher temperature increases rate of reaction. So to have a faster reaction, we take a compromised temperature of 450 degrees Celsius.
Right? Easy. Now this, if you write this, full marks. Done. Now for pressure. Read this. Why do we choose 200 ATM? Why do we choose
Because
that?
it favors
Read it.
high pressure favors a reaction site with lower number of particles. A very pressure will
Very
be
high. Sorry,
expensive and
not a very
dangerous.
pressure. A very high pressure. Okay, it will be dangerous. So we take, okay, 200 ATM. Now let's go downwards. Tell me, write the answer here. Tell me the answer now to this question. Yeah. Why do we choose a lower temperature, not a high temperature? Why? You have written this in your notebook. Check and tell me. Read from notebook.
No, sir, that part I didn't write.
That part, say it again.
I didn't write that part.
You didn't write that part.
No.
You have to write it, Niranjana. How are we going to do this then? So you didn't write any of this?
No, the first part I wrote that we wrote before, but this part,
Which
so
part?
that faster reaction we had to compromise. This part I didn't write.
Write it right now.
Okay.
And Niranjana, if you can remember this, all of this, whatever I've given you to write in your notebook, please make sure you've written it. The same questions will come in the exam. Now the only part left is how to apply the knowledge. Right? So whatever they can ask in the question is now in your notebook. Right? Everything is in your hands.
Yeah.
So please, have you finished writing?
Online, sir.
Done? Now, what about the pressure? Just check if you've written everything. Pressure?
Pressure. I wrote the I part.
Wrote everything? Yes, no.
Wait, I will correct that very high. So you will put an extra class tomorrow or on Friday?
Saturday.
No, Friday or Saturday.
Saturday. Now, oh, wait, no. Okay, I can take the class on Friday. That would be better for me. Is that okay?
So anything is okay for me.
Yeah. So yeah, because Saturday I have other work. So yeah, I'll have to cancel that otherwise. So take the class on Friday.
Okay. So, but at what time?
Same time.
Like
7.
today, 12 o'clock?
Yeah. Not 12 o'clock. No, you have 6 o'clock. 6 o'clock. 6 o'clock. 6. Right? You have classes on 6. Yes. 6 o'clock.
Okay.
I revised the whole thing in one day, right? So if you're finding this understandable, if you have any friends, right? You were talking about Ravan or someone. Whoever is interested, ask them to try out a class, because trying out is free. If they don't find it helpful, it's up to them, right? I want to help people, so whoever is interested, let them know. Now, this one right here. Have you written everything?
So then all I wrote.
Wrote this one?
Yeah, we wrote that one.
This one?
Wait, this one. I
Written?
wrote this. The first part. So 1 minute. So tomorrow I have to tell you how to join the class.
Say that again.
So tomorrow I have to tell you how to join the class.
Yes, you should, as soon as possible.
So
Because
she said that she wants to continue physics because the other she's not comfortable. She's being
I will talk about this afterwards. First, tell me if you finished writing. Let's focus on you. Have you finished writing?
So I have a doubt. So for the sulfuric acid, you showed me like a big rock.
Yeah.
Will they ask us the color or something?
No. Only the things in your notebook will come. If you please memorize everything you have in your notebook.
Okay. So color
Everything
and
by
also
heart. No, by heart in your notebook what you have written. Memorize all of that by heart. Everything, the equations, the sources, the reasons, the explanations, all of that. Okay? You have written this?
Yeah.
Yeah, okay, there's nothing more to this. Done. Now let's get back to the question.
The spelling, one spelling is left.
Which one?
So,
ATM? The spelling of ATM is ATM.
yeah.
Yeah? Got the spelling? Now just answer this one, come on. Why do we need a lower temperature? Say it.
We need a low temperature.
No, wait, so no, read the question again. Explain why.
Explain why a lower temperature and higher pressure are not needed.
Not used. Why?
Why?
Read it from your notebook. Because I'll tell you why. Because we need a lower temperature because we don't take a low temperature because even though low temperature favors the exothermic reaction, it does favor. Low temperature favors exothermic reaction, but high temperature increases rate of reaction. So we take 450 as a compromise. Is that clear?
Okay.
Low temp favors exothermic, but high temp gives higher rate of reaction. So whose shop will you go to? You'll go to higher temperature shop. Why? Because they're giving a high rate of reaction. So 450 C taken as compromise. That's the answer for this one. First part. All of this is 1 mark only because you have to memorize this one. Just the next part, high pressure, is because high pressure is expensive and dangerous. Is that clear?
Yeah.
Okay. Fine, just a second. Right, and last, what is the role of iron in Haber process? What is the role of iron in Haber process?
It's a catalyst.
Catalyst, done. So we got all the marks. Good job. That's all for today. Now, you will find the recording. I've uploaded the recording of the morning's class. I will upload this right now as well. Please revise it, rewatch the recording if you can. Please do that. And that's all for today. Yep. Stay for a second.